All right. So this is lesson 4, section 10.4, hyperbolas for pre-calculus distance learning, number 4. So this is our fourth conic section, the hyperbola. So a hyperbola is made when you take the napped cones, the two cones that are sitting point to point, and you slice them through both cones. So here, the pink is the two cones, the hyperbola is a shape that you get when you take a plane, you slice through it. So you get these two shapes like this, where what's going to happen is you're going to have like a center, you're going to have a distance, vertex, vertex, and then here to like actually graph it out, this shape is going to kind of follow some asymptotes here. So it's going to be curved in this area because it's like on the edge of the cone, so it's got this curve to it. But as it goes out further, it's going to kind of follow that linear pattern that you get from a cone. Because a cone is made by like a circle with straight lines going down to a point. So this hyperbola shape, as we extend like far in the x and the y direction, like far away from the center, it's going to look kind of like this X shape far out. As we're close to the center, though, we get this curved shape. All right, so our learning targets today are to rewrite the equation for a hyperbola in standard form, identify the key characteristics, so like the center, the vertices, the foci, the equations of the asymptotes. I think that's it. And then sketch a graph. It's not going to be a graph like this, it's going to be a graph on the x, y, we'll get to that. And then we're going to write the standard form equation for hyperbola if we're given some of those key characteristics, and then sketch the graph and fill in some other key characteristics. All right, so we talked about what a hyperbola is, what it kind of looks like. Now let's look at the ones that we're actually going to talk about. So we're going to be working, so hyperbolas can be in any angle that you want. But we're going to talk about ones that have what's called a vertical or a horizontal transverse axis. This is an example of a vertical transverse axis because the line that goes through vertex, center, vertex, and the foci would be here and here. That goes straight up and down, so vertical. If we have a hyperbola that goes like this, let's say this was flipped over, like that, this would have a horizontal transverse axis. So I'm going to write the equation, general equation for each of them, talk a little bit about it. I'll try to explain a little bit how to graph it just in general, then we'll actually jump into some examples. So the general equation equations. So this is for a horizontal. Let me use the white pen here. This is a horizontal transverse axis. So here we have x minus h squared over a squared minus y minus k squared over b squared equals 1. Now notice it's subtraction here instead of addition for the equation. And the a squared is under the positive. So if it's a horizontal transverse axis, the x part is positive and we're subtracting the y part. Now for a vertical transverse axis, the equation is going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. So notice when I switch from horizontal transverse axis, one that's opening this way, that's got a horizontal line going through the middle, to one that would be opening this way, like this, that's got a vertical line going down, straight up and down through the middle, that the y part is positive and we're subtracting the x part. Okay, so let's talk about how we go about actually graphing this, finding the foci, that sort of thing, and then what the properties are for a hyperbola. Like what's the set of points? What properties do they follow? So if I'm going to graph this, what I do is I go over to h comma k, which is the center. Let's just say it's right here. So the center's at hk. So center at h comma k. And then here, because I have a horizontal transverse axis, I'm going to go right a distance of a. I'm going to go left a distance of a from the center. Those are my vertices. So that's a vertex, and that's a vertex. Now, remember how I said that we've got these asymptotes that it follows? In order to find those asymptotes, what we do is we use this b value, and we go for horizontal transverse axis. The b is under the y, so we're going to go up or down b. So in this case, A and B, it doesn't matter which one's bigger. The A value is always under the one that's positive. The B value is always under the one that's getting subtracted. So B could be greater or less than A. That part doesn't matter here. Not like with ellipses, where A was always bigger. Hyperbolas, the A squared or the A is always under the positive term. So here, now what I'm doing with this B is I'm finding what I like to think of like the imaginary covertices. They're not actually a part of the graph, but what they do is they allow us to sketch in the asymptotes. So the asymptotes are always going to be intersecting at the center, like we had here, and then they're going to have a slope. In this case, the slope of the asymptote is going to be b over a, and negative b over a. So here the slope of this, so here the slope is b over a, and the slope of this one is going to be negative b over a, because it's going down b, right a. To actually graph in the hyperbola, what we do is we start at the vertex, and we make this kind of curved shape, and then we follow the asymptote. So it's basically, it's not going to curve like this, it's going to curve out and basically kind of look like a straight line. So I start here, curve out, oh, follow that straight line, curve, and follow that straight line. So the orange part is actually the only part of the graph. The rest of this with the dashed lines and everything, that's all our work that we're doing. So the last thing to do is to put the foci on there. The foci are a distance of c away from the center along the transverse axis. And here for a hyperbola, the distance c from the center to the center of the focus follows this rule of c squared equals a squared plus b squared. So our foci are going to be, so focus is right there, and a focus is right there. So, and that follows, like, you know your a squared and your b squared, you add them together, square root it, you get that distance. Now, what do the focus tell us? The focus are the points so here, basically every point on this graph, this hyperbola, if I take this distance from here to the focus and here to the other focus, so D1 and D2, the absolute value of the difference of those two is going to equal some constant. So basically it doesn't matter where I am on this hyperbola. Anywhere that I go, this distance minus that distance, absolute value, is going to be the same number every time. Okay, now if we have a vertical transverse axis, we do basically the same thing, where we find our center. But here, the a value tells us how far up and down to go. So we're going to go up a to get a vertex. We're going to go down a to get a vertex. We're going to go right and left b from that b squared. Once again, b does not need to be bigger or smaller than a. It's just the a part is under the positive and then the minus, so that makes that one b. And then here we draw in our little rectangle so that we can draw our asymptotes. the asymptotes in this case are going to have slopes here. So the slopes of these asymptotes are going to be a over b, because the a is the rise and the b is the run. So here the slope is a over b, and here the slope is negative a over b. And that's because the rise is from that a. Okay, right, then we would just graph it out the same way, but here the vertex is on the top, so it's a curve and then follow the asymptote, curve and follow the asymptote. Point at the vertex, curve and follow the asymptote, curve and follow the asymptote. So these green curves are the actual graph of the hyperbola. We would once again find where the foci are by going a distance of c from the center. We'd get that c by going c squared equals a squared plus b squared, and the foci would be contained inside these curves of the hyperbola. All right, I think I've covered kind of everything that we need to get started on some actual problems. So let's go ahead and get started on some actual problems. So jumping here to example 1. So example 1, what we're doing here is we're taking the equation of a hyperbola that is not written in standard form. We're going to rewrite it in standard form, answer some questions about it, sketch a graph, and well, that's it. So problem 1, we have 25x squared minus 16y squared minus 150x minus 64y minus 239 equals 0. Yep, there it is. So what we want to do here is we basically want to take this and rewrite it in standard form. So similar to what we did in the previous lessons, the previous sections, we're going to gather the x's together, gather the y's together, get the number on the other side, and so forth. So I'm going to take this 25x squared minus 150x, put that together, minus 16y squared minus 64y, add the 239 over, so I get plus 239 equals 239, sorry. All right, so now I want to go about and complete the squares. So I get something squared eventually divided by something minus something squared divided by something. So in order to do that, I'm going to factor out the coefficient on the squared terms. So here I factor out a 25. That gives me x squared minus 6x. And then I'm going to say plus blank so that I can complete my square. And here I'm going to factor out a negative 16 because it's a minus 16y. So here when I'm factoring out this negative, I got to be really careful that I divide this negative 64 by a negative 16. So it's going to give me plus 4y, and then plus blank equals 239. And then what's going to happen here is I'm going to have plus blank, 25 times whatever I get there, and I'm going to have minus 16 times whatever I get there. And that's another tricky part with hyperbolas, is we are adding whatever we get here, but we're subtracting whatever's coming out there. Okay, let's go ahead and complete the squares. Half of 6 is 3, 3 squared is 9, so we're going to put a 9 in there. And then here, I'm going to go 25 times 9. With this one, half of 4 is 2, 2 squared is 4, so I get a 4 there, and here it's minus 16 times 4. So, putting this all together, I get 25. This is going to be x minus 3 squared, because it's a minus 6, so that minus travels down. And I get minus 16 times y plus 2 squared equals, add that all up, and we get a 400, so equals 400 here. Okay, all right, so we added 25 times 9, we subtracted 16 times 4. Now I want it to equal 1, so what we're going to do is we're just going to divide by 400 on each side. This gives me x minus 3 squared over 25 over 400 is going to simplify down to 16 minus y plus 2 squared over 25, because 16 over 400 is going to simplify down to 25, and then it's going to be equal to 1. Boom, there's our equation. Standard form. So now, before I tell you, I want you to think, is this a graph with a horizontal or a vertical transverse axis, and how do you know? Go! And the answer should be that it has a horizontal transverse axis. The reason it has a horizontal transverse axis is because the x part is positive when we're subtracting the y part. Whatever part is positive, this term is positive, that term is subtracted, so that term is negative. Whatever term is positive, that variable tells you what the transverse axis is. So, now we can go about finding the rest of our information here. So our center, the center is going to be at 3, negative 2, because it's the opposite of those. The vertices we need the foci, and we need the asymptotes. Believe those are, and then the graph. Those are the pieces of info that we need to answer. So let's go ahead, we'll graph it, and as we graph it, we'll find this other information out. Here we go. So 3 and negative 2 is our center. So make sure when we're sketching out this graph that we're at 1, 2, 3, negative 2. That's our center. Now, in order to find the vertices, I'm going to go right or left the square root of this. So a squared equals 16. So a equals 4. So I'm going to go right 4, left 4 to find my vertices. So 1, 2, 3, 4, that's a vertex. 1, 2, 3, 4, that's a vertex. So my vertices are plus or minus 4 on the x number. So I have negative 1, negative 2, and I have 7, negative 2. So now we've got our vertices on there. To find the foci, let's find the foci. We're going to use this fact that we have c squared equals a squared plus b squared. That's the relationship between a, b, and c for a hyperbola. And we've got, c squared equals 16 plus 25. That gives me 30, 41. So c squared equals square root of 41. And it's going to be to the right and left from the center. So the foci are going to be at 3 plus root 41, negative 2, and 3 minus root 41, negative 2. Square root of 41 is about 6.4. So we're going to go about 6.4 on our graph away from the center. So we go 1, 2, 3, 4, 5, 6. Right about there, that's a focus. And 1, 2, 3, 4, 5, 6. Right about there, that's a focus. So another focus right there. All right, so we've got our vertices, we've got our foci, we've got our center. Now we need to actually sketch out the graph. And in order to do that, we need the asymptotes. So in order to find the asymptotes, we're going to use the b value. The b value in this case is 5. So we're going to have to go up and down 5 from the center. So 1, 2, 3, 4, 5 right there. 1, 2, 3, 4, 5 right there. And what we're going to do is we're going to draw in this rectangle. That's going to give us our asymptotes. Now, the asymptotes are going to go through the center of the hyperbola, and they're going to go through, they're going to be the diagonals of that rectangle. Basically, they're going to have slopes, in this case, of b over a, or slopes of 5 over 4. So here we got a slope of 5 over 4 and negative 5 over 4, because this one's dropping from left to right. So now to actually sketch the graph, we've got our asymptotes, we have our vertices, we got our foci. Our foci are always going to be inside of our curves, so we just start at a vertex, we make a curve that ends up looking like the asymptote. It does not curve like this. It goes along the asymptote. So here, curve and then follow the asymptote, curve and then follow the asymptote. It's not like this. It's not like if I have a little box, it's not like this. It's not like a parabola. It's along the asymptotes. So if you were to extend it, they would basically look like lines on the outside. All right, so that's a sketch of our graph. Last thing we need is the equations for these asymptotes. So to find the equations of the asymptotes, what we're going to do is we're going to use the fact that we know how to write the equation of a line if we know its slope and a point. In other words, we can use point-slope form. So remember, point-slope form is y minus b equals m times x minus a, where a comma b is the point on the slope, or sorry, the point on the line, not the point on the slope, the point on the line, and then m is your slope. So one of these equations is going to be y plus 2, because we got a point of negative 2, equals positive slope, which is 5/4, and then x minus 3. And we can just leave it in point slope form, that's fine. And then the other one is going to be y plus 2 equals negative 5/4 times x minus 3. So basically when you're writing the equations for the asymptotes, it's going to be y minus b equals m times x minus a, where ab is going to be your center of your hyperbola, and then you're just going to throw in for m the slope of each asymptote. Now, if this was an asymptote where, sorry, not an asymptote, this is a hyperbola where the y part was positive and it was subtracting the x, right? If it had a vertical transverse axis, then the a would be your rise and the b would be your run for your slope, because, well, it would change, right? The a squared is always under the part that's positive. So here, a squared was 16, so a was 4, and that was our run for our lines. And the y part had the 25, so b squared was 25, so b was 5, so that was our rise for our asymptotes. Okay, so that's an example of that problem. Answers all the parts. We'll go to one more, and then I'll let you do so. Then hopefully we'll be ready to do some work. So example 2. So example 2, we're given some information about the hyperbola, and then our job is to write the equation, sketch the graph. I think that's it. Just write the equation, sketch the graph. Yep. Here we go. Let's dry it out. All right, so problem 2, we've got foci at 2, 8 and at 2, 2, and we know that the a value is 2. And that's all the information we're given here. So let's go ahead and try to figure out the rest of it and then write the equation and so on. So we can start with the graph. Notice that x number is the same, the y numbers are different. So that means we're going to have a vertical transverse axis. So to sketch out the graph here, we're going to go 2, 8. So 1, 2, 1, 2. 3, 4, 5, 6, 7, 8. So 2, 8, that's a focus. 2, 2, that's another focus. So those are our foci. And then we've got a equals 2. So that means, well, a squared would equal 4, right? How does that help us? Well, from the foci, we can find the center. So basically, I got to find the number that's halfway between 8 and 2. In other words, I can find the average of those. 8 plus 2 is 10. 10 divided by 2 is 5. Or I could go down 3, up 3, get to 5. So 2, 5 is my center. So the center is going to be at 2, 5. And then I know my a squared, so I can start going with my equation if I want. Because it has a vertical transverse axis, I know the y minus 5 part is going to come first. That's the positive. Over a squared is over 4. And then here I'm going to have minus x minus 2 squared over, I don't know what b squared is yet, so I'm going to leave it, equals 1. Okay, So now, even though this came first, the y still went with the y number in the center, the x still went with the x number in the center. So now we got to find this b squared to finish our equation. So, well, what is c? Right, we've got a equals 2, or a squared equals 4. C is going to be this distance from the center to the focus, which is 3. So here, c equals 3, or c squared equals 9. So we can find b by just basically going, well, c squared equals a squared plus b squared. So 9 equals 4 plus b squared, right? Yep. Which means, right, minus 4, 5 equals b squared. So b equals the square root of 5. But we want b squared here, so this is just going to be a 5 right there. Now, if I'm going to sketch this out, what I'm going to do is, well, I've got my center, my foci, I need my vertices, and I need my asymptotes. So, to find my vertices, I'm going to go plus or minus 2, up or down 2, because a value is 2. Now, I'm going to go right or left the square root of 5. The square root of 5 is just a little bit bigger than 2. Square root of 4 is 2, square root of 5 is going to be a little bit bigger. So I'm going to go left 2, use a different color here. Let's go blue. 1, 2, so a little bit further that way, and a little bit further that way. And then I'm going to draw in my rectangle. Draw in my asymptotes going as the diagonals of that rectangle. Where here, the slope on this asymptote, so here this slope is going to be a rise of 2 and a run of square root of 5, right? Or you could say 2 root 5 over 5. And this slope is negative 2 over root 5, or negative 2 root 5 over 5 if you want to rationalize it. Right? Because the run is root 5 and the rise is 2. Now to actually, there goes pen. To actually sketch in the graph of this hyperbola, what I do is I start at the vertex, don't start at the focus, start at the vertex on that box, that point, right here, and then I make this curve that eventually just follows along that asymptote, and then curve that just eventually just follows along that asymptote. So that's half of our hyperbola. And then we do the same thing on the bottom, curve and follow along, curve and follow along. And there you go. We got the equation, we've got the graph, right? We've graphed everything else. We're happy. That's all we need to do. So I'm going to challenge you. I'm going to make another video to kind of help you out with the other 2 problems on the lesson. But go ahead and try all the problems 1 through 4. If you get stuck, you can watch the other video. But right now you should have enough to at least make a good, solid attempt at the assignment. So enjoy, email me if you have questions, and good luck.